Hello everyone. So today I'm going to discuss an important topic regarding operating systems, that is CPU scheduling algorithms. So in this, there are many types of algorithms. If you understand the process state diagram very clearly, then you use to understand what is preemption and what is non-preemption. Preemption methods in a better way, and even the preemption methods only will be asked in any examination. First, we'll understand non-preemption methods. We'll get an idea how to solve the problem and how to calculate the times and how to draw the Gantt chart. So let's go to the FCFS. Here, coming to the FCFS is nothing but first to come, first to serve. So in the name itself, we can say that is which process comes first. We assign that into the Gantt chart, and we'll make that process to be done completely, and later the next process comes on. So here you can see they didn't give any arrival time. That means we don't know that when the process P1 is going to enter the CPU. So in the default, we can take all the arrival times of all the processes as 0. So main important thing is Gantt chart, which is very important. If you draw this, if you mark the all processes properly, then 90% of the problem is completed. So let's take the Gantt chart. So here always we assume that it was starting with the 0 units of time at the 0 point. Okay, now as there is no arrival time, we are not checking any arrival time, and we'll take the sums processes. So first P1 is getting occurred, so we'll write P1 here, and its burst time is 24. So 0 units of time is done, so 0 plus 24 is 24. Next, the process P2 is getting on. So first come, first serve, as there are no arrival times given. So here 24 and the burst time is 3. So to complete both the processes P1 and P2, total time taken is 24 plus 3, that is 27. And next P, P3. Total 27 plus 3 is 30. Okay. So when there is no idle time, that means here there is no, we are not making CPU idle. Idle is nothing but where CPU doesn't do any processes running. That is known as idle state. Here you don't say any idle state. So the total burst time will be equal to the total completion time. Here the process, all process. That means drew you have drawn the Gantt chart correctly. If this one and this one gets equal, then you made the answer correct. Now you'll have some formulas to be remembered. So first of all, you know some definitions also about what is burst time, what is completion time, what is turnaround time, and what is waiting time. So here, let's understand what is turnaround time. Turnaround time is nothing but completion time minus arrival time. Next, waiting time is nothing but total around time minus burst time. So these two formulas are very important, as in every question they ask about average turnaround time and average waiting time. So burst time is completed. Now let's calculate completion time. Completion time is nothing but how much units of time is required for each process to complete their running task. So for P1, the completion time is 24. It's very easy to identify the completion time, and P2 it is 27. The right side value for our final process number is known as completion time. For P3 it is 30. Okay. Now we'll calculate turnaround time and waiting time. So turnaround time is nothing but completion time minus arrival time, as here the arrival time is equal to 0, as it didn't mention any arrival times. So it is as it is 24, 3 and 3, and in waiting time we'll have 24 minus burst time, 0, turnaround time minus burst time. Oh, sorry, 27 and 30. Next, 24 and 27. So average turnaround time is equals to 24 plus 27 plus 30 divided by 3. And average waiting time is equal to 0 plus 24 plus 27 divided by 3. So in this way, we solve the problem of FCFS if they didn't give the arrival times. For suppose if they give the arrival times, this problem. So as I told that we will assume every time that processes are running from the 0 unit of time. So and here Let's see, is there any process arriving at the zero unit of time? Before, we don't have any arrival times. So directly we made the problem as each process is coming and its first time and adding them. But here as arrival time is given, so here you will see, is there any process is entering at the time of zero unit of time? Yes, there is P2. So we'll write P2 here and its burst time is 1. So 0 plus 1, 1. So we'll add here 1. And here you can see, is there any process coming under 1 unit of arrival time? No, there is no any other process coming here. So what you will do is, this time is known as idle time. So this time is known as idle time. So now we'll write here 2 because the next arrival time is 2 in the given question. So at 2, is there any processes coming up here? Yes. So what are those processes? That is P1 and P3. So P1 and P3. So according to the FCFS, the first come, first serve. So according to the processes that we have written in the order, the first one coming here is P1. So here we are writing P1. P1 burst time is 2. Already there is a completion time of 2. So 2 plus 2 is 4. Next, we'll write P3 as P3 is also there. And here you will have a doubt, that is 4 is arrival time. So what are all there at 4 that are arriving? So P3 is there, P4 is there and P5 is also there. But as this is FCFS, so we'll see first come, first serve. So P3 is coming. So 4 plus its burst time is 3, it is 7. Next we'll write P4 and its time is 7 plus 5. 12 and P5 is 16. So, as I already told that whether your answer is correct or wrong, you can recheck with the summation of the burst time. So, this is burst time. We'll add all these values like 10, 11, 12, that is 15. So, you'll have a doubt that you told that whenever the completion time of all the processes is equal to the burst time, then it is correct. But now there is a difference 1. So, why the difference is there means, here you can see the idle time where CPU is not working at the time because there is no any process coming at the time. So here we are using 1 unit of extra time. So here we got 1 unit of time as incremented. So this is also correct. So when there is idle time, compulsory you will get 1 extra unit of time at all the completion times. So you have to observe that, and this is also right. Next, completion time. So completion time means for P1 it is 4, for P2 it is 1, for P3 it is 7, for P4 it is 12, and for P5 it is 16. Yes, correct. I'm rechecking the problem. Okay, turnaround time is nothing but the completion time and the arrival time. So here already I mentioned the formula, so please remember this, important. So completion time minus arrival time 2, 1, 5, 9, and here it is 12. Waiting time is turnaround time minus burst time 0, 0, 2, 4, 8. So you can understand easily what is average turnaround time and average waiting time. So this is about the FCFS. I hope you understood. If you have any doubt, you can ask me in the comment section.